Hello and welcome to screencast number 7. We're in chapter 21 and we're almost getting to the end. We're looking at new renewable energy alternatives, and we're going to consider geothermal energy in this screencast. So geothermal energy is the energy that arises from beneath the Earth's surface. It comes from radioactive decay of elements, and that they're in just extreme high pressure deep in the interior of the planet, and that generates heat that rises to the surface. Also, this heat rises because of magma or molten rock, and it goes through the cracks and fissures that are present. And where this energy is, it heats up the groundwater. And of course, we know when you heat up groundwater, there's going to be an expansion. So this naturally spurts the heated water and steam are sent up from below and kind of erupt through the surface in little geysers. And we're familiar with Old Faithful, so there's an example, and it actually takes a certain amount of time so that it reacts around the same time every single day, and it does this so that the pressure can build up. Under the ocean, we have submarine hydrothermal vents that the hot water is coming out. Iceland has a lot of geothermal energy as well. The geothermal energy manifests itself at the surface in these ways, in these certain areas. And there's regions that, when we say, well, okay, is this all over the place? No, there's different regions that exist where it's more effective, it's more active. One of the most active areas is California near the Napa Valley, and they've used that area where they have developed a geothermal power plant that they call the geysers. This was established like in 1960. I mentioned Iceland has also a lot of geothermal energy there. There's a lot of lava that comes out through the Mid-Atlantic Ridge, so they rely on that energy. Any area that you're going to have volcanoes and geysers, that's going to be the area where you can get the geothermal energy from. So the way that we harness this geothermal energy is just directly from the geyser surface. Most often from wells that will be drilled down hundreds and thousands of meters toward the heated groundwater. That hot groundwater that can then be used directly for heating homes. You don't have to heat it, it's already there. Offices and greenhouses. It's great for driving industrial processes and for drying crops. Iceland, as we've already mentioned, heats nearly 90% of its homes through the direct heating with this piped hot water. And the direct use of naturally heated water is very efficient and inexpensive. But the question is it feasible? It's only feasible where geothermal energy is readily available and does not need to be transported far. Geothermal power plants can harness the energy from the naturally heated underground water and steam to generate electricity. A power plant brings in water at temperatures of anywhere from 300 degrees Fahrenheit to 700 degrees Fahrenheit. So it converts this to steam by lowering the pressure in specialized compartments, and then the steam turns the turbines to generate electricity. The world's largest geothermal plant is the geysers, which we've already mentioned in California, and it provides electricity for 725,000 homes. So globally, 1/3 of the geothermal energy we use is for electricity, and 2/3 is used for direct heating. So let's take a look at where we see these within the United States. And as you can see by this, the geothermal resources in the United States are more in the Great Western states, with the darkest colors, and there's our darkest colors, being at 250 degrees Celsius. and our lightest colors are blue, which we're on the edge of that, being at 50 degrees Celsius. All right, so let's take a look at these two diagrams of geothermal energy, and the one is of a geothermal power station in Iceland, and I'm not even going to try to pronounce the name of this. So taking a look at the geothermal power plants, the way that they generate electricity is using this naturally heated water from underground. So we can see here at the bottom, this is the magma that is going to heat the groundwater. Some of this will escape through surface vents, such as geysers. So we know about Old Faithful. So here's a fault, here's a geyser that is created that is releasing some of the steam from the heated water that exists. The power plant may tap into the heated water, and they can channel the steam through the turbines. So here's where they're tapping in to this, and they're going to use that steam in that turbine center right there. And then once used, the steam may be condensed into water and pumped back into the aquifer to maintain pressure. So this is an injection well, and we're putting that right back into this aquifer so that it maintains the water. At the Iceland's power station, here, ooh, I didn't mean to do that, that we see in this picture. See, it's a big, complicated setup. Look at the steam that's coming out from that. The steam piped in from the wells heats the water from the lake, and then the heated water is sent through the insulated pipeline to the capital city, where residents use it for washing and for heating their buildings. Okay, so as we have discussed throughout this chapter and previous chapters, we've got benefits and we have limitations. So let's focus on the benefits first. And the benefit of geothermal energy is that it does reduce emissions relative to the fossil fuel combustion that we've been comparing everything to. It's heated water, and it can release dissolved gases. The dissolved gases are carbon dioxide, methane, ammonia, and hydrogen sulfide. And these gases generally occur in small quantities in comparison to the fossil fuels. There are facilities that have filtering technologies that can even produce less of amount with that. So when we look at the megawatt of geothermal power, we're looking at about 15.5 million pounds of carbon dioxide that is being released each year in comparison to the tons that we were talking about with our fossil fuels. In principle, the geothermal energy is renewable because using it does not affect the amount of thermal energy that is underground. But there's several things that we need to think about, and not every geothermal power plant will be able to operate indefinitely. The reason why is because if a plant uses the heated water more quickly than the groundwater is being recharged, they're going to eventually run out of water. This was occurring at the geysers in California. So what they did is they started to inject municipal wastewater into the ground to replenish the supply. More geothermal plants worldwide are now injecting water back into the aquifers to help maintain the pressure and to sustain the resource. Going a little bit ahead of myself there. A second reason geothermal energy is not always renewable is because of the patterns of the geothermal activity and the shifting of the Earth's crust. This happens naturally over time. So as a result, an area that might have produced hot groundwater may not always do so as the tectonic shift. The water of many hot springs is laced also with salts and minerals, and these can corrode the equipment as well as polluting the air, and the factors may shorten the lifetime that the plants can actually be working, and it can also increase maintenance costs and add to pollution. So places like Iceland and Northern California and Yellowstone National Park, they may be rich in naturally heated groundwater, but they're limited. The world does not have access to places like that. So there are a little bit of alternatives that are available, and engineers are currently developing something called enhanced geothermal systems, or EGSs. In this approach, engineers will drill deeply into a dry rock, and they'll fracture that rock, and then they will pump in cold water. That water will become heated underground, and then it's drawn back up and used to generate power. The EGSs thereby use the natural thermal energy underground, but supplies the water, which can be reused repeatedly. We could use EGS widely in many locations. Again, Germany has a little heated groundwater, and they've done their feed-in tariffs to enable the EGS facilities to operate there. EGS technology shows some promise. Again, it shows some negatives as well. In 2006, a report estimated that the heat resources below the United States alone are enough to power the world's energy demands for several millennia. And the EGS also appears to, one of the problems is it appears to trigger minor earthquakes. If we could develop ways to use EGS safely and reliably, our use of geothermal power could remain more localized, more than our solar, more than our wind, and more than our bioenergy or hydropower could be.